So today we're going to be talking about the SPC or Statistical Process Control module for Dream Report. The SPC module is an add-on option, so it's a license add-on to any core or base Dream Report license that gives you the ability to perform SPC reporting on data from any data source. So this includes, as always with Dream Report, real-time data sources, so pulling data in from your SCADA systems, your HMIs, directly from your PLCs in a process that you might want to look at the data in a SPC context. Historical data sources, so a lot of you are probably using process historians. Maybe you don't have a historian, you have traditional HMIs with all proprietary log files in there that you want to look at the data in an SPC context, or even dedicated data logs. Take, for example, a Yokogawa or a Eurotherm data logger that have their own internal data log formats that you want to look at that data again from a statistical process control perspective. And then open data sources. You might have data coming out of CSV files from devices, business databases. Maybe you have an existing lab system or quality system that's based around a SQL database that you want to combine SPC charts from that data along with all your process data and your traditional reports that you're using Dream Report for. And then finally, if your data doesn't exist anywhere, you can certainly manually enter the data using Dream Report's web manual driver, which allows you to create your own little data entry forms from a browser and let your users manually enter data that can then be used to feed your SPC charts and tables and calculations. You know, we're also used to looking at our process data in the context of time-based charts and trends and tables. But when you look at this data in the context of statistical process control and statistically looking at it as opposed to looking at all the raw data, you can really achieve such gains in terms of increased profitability, process quality, and consistency. That's really the name of the game here, is consistency in making a product and how you make the product and the quality of the product itself. Better understanding of your process, looking at maybe machines or tooling wear over time and seeing does your process quality go down over time relative to number of cycles on a piece of equipment. So all of those type of things help with your improved prediction of performance, quality, etc., and so much more, looking at your data from an SPC perspective. So there's several components that make up the SPC module in Dream Report. These modules include the SPC Definition subsystem, which really lets you define what your SPC functions are, the spec limits, control limits, etc., and then a bunch of graphical objects and calculations that are enabled with SPC module. So the SPC configuration is an interface for defining your data collection parameters, your upper and lower limits, where the tags come from, your sampling methodology. All of that is defined in the SPC definition window. We then have a set of 4 SPC-specific charts, X-bar and range or R charts, S or standard deviation charts, and histograms. These are probably the most commonly used control charts, SPC charts. And we chose to include these 4 specific charts because, you know, there's a lot of very good SPC packages on the market already, very dedicated quality lab systems. Chances are your company might be using those already. But the feedback we continue to get from customers is that we want to include a control chart or a histogram or a range chart along with our production reports. So we've really identified the most commonly used and requested SPC charts and made them available to Dream Report to include in your reports. We have added a couple of SPC-specific tables. One is the raw SPC values table, which shows you for each sample the raw measurements and the core statistics about each of those measurements. And then a histogram table showing your data distribution, just as it would be shown graphically in a histogram chart. We have the histogram table. And then a set of about 20 SPC-specific statistical functions. So already Dream Report has around about 45 or 50 built-in calculations or statistical functions. These are SPC-specific, so calculated upper and lower control limits, CP or CPK, process capability. These are very important or key indicators in an SPC initiative. So these are all exposed with the SPC module. The SPC definition window, as I mentioned a few minutes ago, this is really where you set up your spec limits, how your sampling will be performed, where your data is coming from. So let's just take a look at some of the key features and the different options we have in setting up an SPC definition. So first of all, like anything in Dream Report, you need to have a data source to feed your reports. So in Dream Report, we have two ways to get data into an SPC calculation or a chart. Either the traditional way of getting data from a tag-based data source. So it might be a process historian, an external historian. It might be directly from the PLC and Dream Reports logging the data for you. But again, we're looking directly at data points or data items or tags coming out from a traditional data source. The other option is an SQL query. So either if you know how to write your own queries or use Dream Report's visual query builder, if your data is already contained in one or more tables in another database somewhere, we can build a query that extracts the data, and then we can use that extracted data from the query to feed the SPC reports. The next thing is, do you want to report on the raw data, or do you need to pre-process the data in any way? So for instance, you might want to apply a correction factor. Maybe you just need to scale all the raw data before you do the SPC calculations. So you can just do a simple mathematical factor on the data. Or maybe you need to come up with your own kind of pre-processing of, let's say, extract 15-minute averages, and those are the values we want to use in the calculations, or bring me the first sample every minute and use that. So Dream Report allows you to use the aggregated data filter, or ADF functionality, which has existed forever in Dream Report, and apply that to the raw data before the SPC calculations and charts take over. But you want to filter the data in terms of dealing with the raw data. Before you report on it, you want to filter. So you might have a continuous stream of data coming into your historian or your data source, but maybe you want to filter out to only use the SPC, the data in the SPC charts when the motor was running or when the batch was running and that there was product in the tank. So you can apply additional filtering on the raw data before you start actually doing the SPC calculations and charting on that data. So that's handling the raw data and how we might want to pre-process or filter it before we do the charting. Then we talk about the calculations or the sampling for the calculations. You know, with SPC, typically you're not working with individual values, but rather a sample, a statistical sample. And there's two ways to handle that. One is time-based. So a good example for this is if you have a historian which is continuously logging process data. This is really not a traditional SPC application, but more and more customers are looking at historian data in an SPC perspective. So it's not like you're taking measurements individually, but this is just a constant stream of data. So in this case, it might make sense to do time-based SPC, where let's say we say every minute, give me the first 4 samples. And those 4 samples are going to, or 4 measurements are going to create my sample. Or every 8 hours, give me the first 2 measurements or the first 10 measurements. So that's, we tend to see more with historian-based data sources where you'll do time-based sampling and then X number of measurements per sample. The other is the more traditional, where you just say, I've got my measurements are being recorded in my database or in my wherever the data is going, and just keep pulling out every 5 measurements, make up a sample. So that's your sampling methodology. Now, some of this terminology I'm using is very specific to SPC, or Statistical Process Control. To me, it's a fascinating topic, and I try to learn as much as possible about it. So if there are some terms we use here, Google's your friend, look them up, or ask me, and I can try to fill you in. Then we talk about spec limits. Everyone wants to know, how do I specify my upper and lower limits? What's my target that I'm going for? So for instance, this might be a target temperature of 950 degrees when there's a, let's say it's a heat treat process. And I want to see how I'm working in that range, so I can set a lower spec limit of 925, for instance, and 980. So that's hard-coded for this specific SPC definition. And when I'm done, I'll hit the plus sign. But these don't have to be hard-coded. We can also dynamically apply or assign upper and lower and target limits. These could be calculated objects on a report. So maybe depending on what product you're running, you know the spec limits are going to be +5, -10. So you do a little calculation on 2 expression objects in Dream Report on a report, and then reference those in your SPC definition. So this F hash, that's our dynamic token, that's referencing an object on a report. Or maybe it's depending which product the HMI says we're running or the PLC is running, maybe it has tags which has the current target upper and lower spec limits. We can reference those tags directly. Or very commonly is you have a master spec list in a SQL table or some database where you want to look up, depending what you're running, you actually want to query the upper and lower and target limits. So those might be three little objects on a report that you then reference just by double clicking in these cells here, referencing the object on the report to get me my target, lower and upper spec limit. And I will demonstrate this in our last example today when we get into the product. The last thing that SPC needs to know is how you're calculating control limits. So you have spec limits, which are the physical tolerances. Let's say you're looking for a diameter of 10 centimeters plus 1 centimeter minus a half centimeter. So those are your spec limits, but control limits are the calculated ranges that you want to work in. And there's no one way to do control limits. Dream Report calculates them based on one of 4 industry standard ways. The first is based just on the standard deviation of the data. It will then calculate the upper and lower control limits. Then the other options are based on range averages or standard deviation averages with or based on a set of coefficients or constants. So this is just you can look these up anywhere. So behind the scenes, we calculate the upper and lower control limits based on these accepted coefficients. And really, this is the most commonly used method, I think, in industry, and that's our default. And then finally, you can also just say make your spec limits mirror your control limits. That's an option. So really, for every SPC definition, you have the option to specify how the calculations will be done. In my opinion, you probably want to be consistent across all your SPC definitions. All right, so that's what you're going to do, or will do, before you start actually building your SPC charts and tables. You have to define where your data is coming from and how the sampling methodology and calculations are going to be performed. One other thing to bring up here, important to note, is that Dream Report has full implementation of the Nelson rules, or also most commonly, I guess most people know about the Western Electric SPC rules, which is a set of 3 or 4 basic rules. The Nelson rules really are an extended set of Western Electric SPC rules. And these have to do with highlighting or alarming your SPC points on a chart based on one or more of these rules being violated. And so again, these are industry standard quality type rules. Let's say if you have 1 point more than 3 standard deviations from the mean, that's rule number 1. If that point is plotted on a chart and it violates one of these rules, it will then show up with a red dot showing that it's in an SPC alarm. And again, you can choose which of these rules on a per chart basis you want to enforce on a control chart. All right, so that's the background to Dream Report. I just wanted to introduce the key features of the product, the type of charts, tables, calculations we have, and then the setup steps. Now what we're actually going to do is start reporting. So let's jump over to our Dream Report server, and on it, on my machine, I have a Dream Report project. And let's see what we have in this project. Right now, just have a blank report here, nothing else. The only kind of configuration I've done in this project so far is set up my communication drivers. So this is our connections to different data sources. So one of my data sources, for instance, is to an OPC server. This OPC server is simulating a PLC, just pumping out raw data. This might be quality samples or anything from a process. I have Dream Report logging those points into the internal Dream Report database. I've got our demo database that we supply with every install of Dream Report, and this has a bunch of batch data from a batching system I'll use in one example. And then my last example is behind the scenes. I have a SQL database which has a whole bunch of tables in it. For instance, my SPC measurements, I've got some SPC products. So this is a typical SPC type database that I want to map into and use that as my source of data for these reports. And that was done just simply mapping into these tables using the Dream Report ODBC connector. So once you've established your connection to your specific data source or data sources, then you're ready to start setting up your SPC definitions. So because I have an SPC option enabled on my license, this menu choice is enabled up top here, the SPC menu choice. And this is our SPC menu bar with the various definition or configuration and then drawing objects that we have to utilize. So let's start off by looking at our SPC definitions. So the first SPC definition I'm going to create, I have one here already, we'll come back to this one later on, but I'll create a new one, and we're going to call this QC test 1. So it's just a descriptive name, for this specific SPC definition. And the next thing we tell Dream Report, where's this data coming from? So in this case, I'm going to go and actually use one of my points that are coming out of the OPC server that Dream Report is logging. So I'll browse for that, and it looks like there's a couple of simulation items being logged. So we'll choose that test parameter number 1 from the PLC. Do I want to apply a correction factor or apply an aggregated data filter here? That's certainly what we could set up over here. And then finally, let's say how we're going to be recording doing the SPC calculations. What's my sampling methodology? Since this is a continuous stream of data coming out of this PLC, I'm going to say let's grab the data let's say every 1 minute. So let's choose every 1 minute. And then I would like to take the first let's do first 4 samples or first 4 measurements every minute from this data stream and use that for each of those 4 measurements to create an SPC sample. And then I say add it to my list. So that's step number 1, is create an SPC definition. And but I'm not finished yet. I jumped the gun here. I had left over from the previous configuration. I need to change this. We need to set up some limits here. Now, since I know this is a static set of data, not a static, it's a known variable. So what I'm going to do then is set my target for this specific test. Let's say it's a hardness test or whatever's the specific parameter that's coming out, or maybe it's pH. In this case, let's say it's a pH meter, and we need to keep our pH in a certain range. So maybe my target is 5.5, my lower limit might be 5.0, and my upper acceptable limit is 6.5. Okay, so now we have this SPC definition configured and now ready for our reports. So we have that done, and now we want to start putting together an SPC report. So let's create our first report here. In this report, I'd like to create a new report. Let's just call it, what do we call it? Let's give it a name. Quality data. Quality data. And for now, let's just say the format will be landscape, and we'll just do some basic formatting there. Okay, so here's our drawing space in Dream Report for us to start building our reports. So now we have access to these SPC drawing objects. So I'll start off by putting an X-bar chart, and I'll put it up at the top of my report. And let's say we'll put it here. And in here now, the first thing it says is which SPC definition are we going to use? So I'd like to use that test, the QC test that I just defined. Over what time period? Let's say this is going to be for the last, let's say current, let's say 30 minutes. So this chart by default will always look at the current 30 minutes. And now we can set up what do we want to show on this chart. So maybe I want to show my target line, and I'd like my target line to be in, not my text, but my target line maybe to be in green. My lower and upper spec limits, I'd like to be in red. And then do I want to show my calculated upper and lower control limits? So this is based on the range average, or the control limits based on the standard deviation average. I'll do those based on the XR average. So let's do that. Then maybe I want to show those text to the right instead of on the left of the chart. What colors do we want? Oops, do we get those? Do you want to set up different colors for these? Let's say I would like to do those in purple, and I'd like them to be dashed or solid. So again, these are all completely configurable. So what I'm actually going to do through all these, I'm going to do basic setup, and then I'm actually going to apply a completed report. So I don't have to spend too much time making things look pretty now. The main point is just to show the setup of each of these objects. So we've set up on this report, for instance, on this control chart, typically you'd show a target, upper and lower spec limits and control limits as well, but you can add additional lines, plus, minus 1 or 2 or 3 standard deviations. So that's all set up over here. The next is what happens if we violate one of the SPC rules. And if you forget what the rules are, if you just click on one of these, you'll get the description below. So I'm going to randomly pick, every other one, just to include in my report. Okay, so we've told the chart how it needs to look. We've said look at this data always for the current 30 minutes. The line style, do we want to put a legend on this report? Not necessarily. Under appearance, let's just put, say, X bar chart. So X bar is an average chart. Every 4 of those measurements make a sample, and that's what we get will be plotted. Show the values on the X and the Y axis. Don't need a grid. And let's leave that, and maybe put an X-axis. We said this was a pH reading. The title will be bold. And let's see what the basic layout is. Okay, so there's my basic layout for my X bar chart. This is just a representation. This is not what it'll actually, it's not showing all the limits and the colors changing, etc. here. This is just the layout in Dream Report Studio. Next thing I'd like to do is quickly put a range chart. So what a range chart does is shows us the range from the greatest and smallest to the largest for each of these measurements. So if you had 4 measurements that were 2.2, 2.8, 9, and 10, the range would be 10 minus 2.2 being the smallest. So that's what a range chart does, is gives you the range of measurements in each sample. So again, I'll choose my same definition, SPC definition. Everything I'll leave the same. Again, what do I want to show here? I just want to show the, yeah, let's do all of those. Upper controls, lower control, and don't need to show the average. That's fine. Okay. And our appearance here, again, let's make this, we know the range will always be 0 based. You'll never have a negative range. So over here we'll say range chart. Okay. And then the last object to put on this report is going to be a histogram. Show me the data distribution. One last time, pick my definitions here, my QC test definition. These values are a pretty small range, so I could either make a bar for every individual value. Rather, I'm going to say each bar is going to be a range of 0.2 on my pH meter. Okay, so it's 0.2, 0.4, etc. So that's what each bar will represent, number of readings in each of those ranges. So we've got that set up. Any special lines to include on our histogram? Sure, let's put our upper and lower spec limits in red. Let's also put plus and minus 2 sigma. So we'll put over here plus 2 standard deviations. And minus 2 standard deviations. And those are our specs, and we'll do those in red again. And finally, let's actually put our average. Where's our mean sitting right now? We'll do that in green. Do we want to show distribution line over the histogram? Sure. So let's do that, and we'll do it in purple. Okay. And appearance, we'll just put histogram. Okay, so now we've set up our charts. You can choose what style of the charts. Do you want them to be flat? You want a nice little kind of a 3D look of things, but we'll leave it pretty simple for now. And this is our SPC distribution. So that's looking at a set of graphical objects, SPC charts. You might want to put an SPC table on the report to actually show what each of these measurements were. Each sample and what the measurements were per sample, and then the min-max average or standard deviation or range per sample. So over here I might want to put a process value table and draw it in over here, and let's again choose our test. And then in here we are now going to look at what do we want to show? The samples, sample number. So we'll just put over here the caption. We'll say this is number, sample number. These are the values, average, range, and just save space, standard deviation. Okay, and this is going to be SPC samples. And again, a fixed period over the current 30 minutes. And what will actually happen, hopefully I've left myself enough room here. If I haven't, I should just resize this. I could, you know, it might be easier for us just to put it on a second page. So I'll just cut it from here, insert a new page onto my report. So we'll go down to page 2, drop it in here. And now All we need to do is, this will actually grow, this table will grow as needed. So this, maybe our values, and then our average, range, and standard deviation. So we know that we had 4 measurements per sample, so it's actually going to have, instead of values, I could say measurements. Measurement, okay. And so this will actually grow when we run this report. So there's a very simple SPC report setup. And so now if I wanted to run it, assuming I got all the parts and pieces in place right, this is my first attempt at the SPC, basic SPC table or report. And here we have it up, and let's go and generate this report. Okay. So in this report, we have our sampling. So we said the last 30 minutes. These are the samples taken once a minute. Each one of these is, so here's our target was in red. Looks like my range is off a little bit. My control limits in purple, my range of data, my histogram with distribution, my data actual distribution. And if we go to page 2, my SPC measurements. So we said 4 measurements per sample. So for each of those samples plotted here, this is the raw data from the database once a minute, and then what was the average, the range, and the standard deviation for both. The last thing I might want to put on here is maybe a key SPC calculation. Is my process in control? It looks horribly out of control, but that's okay. So let's go and choose a single data object from Dream Report, and let's put over here, we'll call this our CP or CPK. So this is my process capability. I choose my tag again, which was our test, and what statistical function do I want to use? Since we have the SPC license enabled, we get access to all of our additional calculations or functions here. So I'd like to show my CP value here and for that calculation. And then we can do things, I know, for instance, if your CP above, below 1.0, it's not great. So you might want to actually then say, if my CP was from 0 to 1, showed with a red background, from 1 to, let's say 1.33, put it in yellow, and above 1.33, things are looking good for us. And let's just make some high number. Okay, so with that then, we have an SPC calculation that when we run this, we should then have that calculated based on that time, the sample set we have, and we'll see things are not looking good. This data is very out of control. It's distributed all over the place, so I got to really work on tightening up my process. Okay, so the end game here, I'm going to actually apply a finished report, which is what I built ahead of time. So the nice thing about Dream Report is you can create reports, save them as templates. I'm going to go now take one of those templates. So I'm going to apply a report template. Sure, I'm going to overwrite what I just did. And let's go and find it. And this was my SPC analysis report. Okay, so pretty much the same thing, XBAR, R, and histogram. I have the same SPC samples. What I did want to show here is I put 2 single data objects, which are our date and time objects, to show me the time range. So I've said always show, what did we set this up for? 30 minutes back from, so it's a moving window of now back 30 minutes. So if I were to reload this report now and generate it from our runtime management console, here is my report, my target, my spec limits, and how, again, looks like my data is still pretty widely distributed. You want a nice narrow distribution in your histogram for SPC, but there's that finished report. Now this report can be scheduled to run, say, on demand, can be triggered on some condition, it could be scheduled. Of course, the other way to get to it is through the Dream Report web portal. So this is set up, this report by default, we've set up for a moving window of the last 30 minutes, but we might actually want to look at it for a different time period. So by clicking on the new dynamic report button, I want to say, show me the last hour, the previous hour's data. Right now in Boston, it's 11:32 a.m. Whoops, and I didn't set up forgot to configure the web portal, configure IIS. Let's try that again. Whenever you change projects in Dream Report, don't forget to rebuild the website for that specific project. So now we can open the web portal and do that again. And fixed for the last 1 hour and generate the report. Okay, so the last hour is 10 o'clock to 11 o'clock. Right now in Boston, as I said, it's around 11:30 a.m. So here we have the last 1 hour's worth of data from 10 o'clock to 11. The last completed hour, my SPC chart, and my samples over that time period. Okay, so that's using a static set of spec limits. So it's a specific parameter we're looking at from our PLC. It has known upper and lower limits and target. And so that is what we've done in this example, was to take those and to just create an SPC specific report. The next thing I'd like to do is create a new report here. Let's just call this a batch report. And I'm going to, before I do anything, just apply a existing report template to here. So I have a batch report that I've already built, and this is all, it's batch based, obviously. So I'm going to apply a report template. And I have on my report template, this is actually one of the reports from the Dream Report demo project that comes with the Dream Report. And we're looking at tank temperatures and levels, etc. I'd like to add to here a control chart to see how my temperatures, how I'm maintaining temperature within the context of a batch. So instead of me starting from scratch and choosing a control chart, etc., I can use one of my charts I've already built from one of my other reports and just drop them on here. But before I do that, I do need to set up an SPC definition. So I'm going to create a new SPC definition now. And in this example, we're going to use a tag from our process database. So we'll call this one tank1 temperature. It's coming from an external history server, which was our process data source. And I want to get temperature 1. And for this one, we will do it sample-based. Let's say every 3 samples, and my target for, no, actually we'll do it time-based this time. So we'll do, again, time-based. So these batches run long. They run probably about 100 hours a batch. So let's take, let's say, 3 samples every 8 hours, just to get a good idea of what's happening over the duration of this batch. And again, my target now is 85 degrees is the target, 85 degrees Celsius. My lowest spec limit will be 80 degrees, and my upper is 90. So we have more flexibility on low. We don't want to go too high. Okay, so there we have now our temperature spec limits for tank 1 and added as a definition. So instead of me doing all of these from scratch, I'm just going to copy a couple of these. So I will copy my X-bar chart just to see how easy it is now to apply it. Let's bring it down here, make it a bit smaller so it fits. And in this X-bar chart, there's a couple of things we have to change. If you notice in any of these objects, the time period for all of these is batch-based, not time-based. So we're going to say for the last one batch. So likewise, for this control chart, I want to choose, well, first of all, I have to change my data source. So I simply change it to my temperature 1 data source instead of that QC test from the previous example. The time period is not time-based anymore, but it's now batch-based. And we've set up an ODBC batch, a Dream Report batch definition over here already. And appearance, we're not looking at pH, we're looking at degrees Celsius. And I'm going to leave everything like that as X-bar chart. Tank 1 temperatures. Okay, so we have a little chart there. And on page 2, let's copy and paste the histogram, see how my temperature distribution looks. I'll copy that, put it on this report, and for this one, let's set it up to have, again, we're going to change our data source from QC test 1 to temperature. My ranges of my temperature are a lot bigger, so I'm going to say for this, let's put a temperature range of 2, not 2.0. And again, it's going to be batch-based over this last batch, and histogram, temperature distribution. Okay, and we'll do that and leave everything else as is. All right, so we've set up now, taken the existing report and added a control chart and a histogram. So let's reload our report. And if I generate this for the last batch that ran, so this batch 615 started on May 31st and ended on June 4th. So it was a 104-hour long batch. That was a pretty long batch. This is all the process data that we're used to seeing it in this context. But now, under our SPC chart, we see our values, our samples, taking 3 measurements every 8 hours and plotting them over the course of this batch. It looks like we've definitely violated some of the SPC rules, so we need to look into that. And on the second page, we look at our data distribution, a little bit more normalized, which is good. We have a few outliers, but generally we tend to be, most of our data is in spec. We tend to be, looks like we're running a little hot most of the time, or a lot of the time. And here we're showing the lower and upper spec limits, the calculated average, and then our plus and minus 2 standard deviations. So again, you're looking at this data in a very different view than, say, you would be on a traditional line chart, which is just raw data plotted over time. Same data, but completely recontextualized and kind of redisplayed in a different context. This might be more useful to a process control engineer trying to fine-tune a process versus a quality person trying to understand the impact of the temperature on quality and seeing when we do have spikes or we do drift in a certain direction, what is the impact of this process variability on our product quality, for instance. Okay. And again, this might be triggered automatically at the completion of a batch, or a user on the web portal might come in and say, I need to bring up, there was a batch that ran, maybe you didn't even have these reports, the SPC options on your batch reports, which have been running for the last few years. You've just added it to the report, but now a customer calls in and says, listen, we've got a problem with an order we placed with you 2 years ago, and we'd like to just see if you were aware of any anomalies. So while the report that ran 2 years ago didn't have the control charts in it, I can simply come back in here now and from the web portal, create a new dynamic report, and it's now going to be batch based. I don't look at the last batch now, but rather I actually want to look up that batch, and we find all the batches that ran. That was an old batch, so let's say batch 440 and generate that report. And let's see if we can generate this report from, well, it looks like there's all gaps in the data. That was no wonder those problems. And lots of gaps in the data. So there's obviously a lot of missing data there. Let's try a different one maybe that shows a slightly better view of the data. So we can choose not the last, but an absolute batch. Maybe something more recent, which I know has more data in it. Let's see, I don't know, maybe this one. So again, generating the report on demand through the web portal. And then, so this ran back in July of last year. And here's our process data and our SPC distribution, our data distribution added into that report. And so based on this then, looks like our data was violating all kinds of SPC rules. We can now start digging deeper into our raw data or into our quality samples or anything else based on this time period. And now we've narrowed down when the issue was and what we need to start looking at. Okay, so now we've created one report from scratch. The other one, we took an existing report in Dream Report and we've added SPC capabilities to it. And the beauty of this, of course, is now you can start to contextualize your data. You might have data from a quality system, you've got data from your process historian, and you're bringing it together and forming these reports or laying them out that meet your needs. One of the challenges that a lot of end users have with dedicated SPC packages is while they give them every calculation and every chart under the sun possible for an SPC report, when they need to include that type of functionality in their production reports, their manufacturing reports, their certificate of analysis they send out to their customer, it's very hard, if not impossible, to take data from those other systems. You have to send a report from a different system and kind of staple it and attach it to whatever else you're producing. This, of course, with Dream Report allows you to contextualize this data, bring data and from all different data sources and different types, and bring it together into a single unified report, which is, to me, such a useful feature of this. Okay, let's move on to the last example now. And this is to do with dynamic SPC lookups. Jumping back to my SQL database, I have a couple of tables here. One of them, and this is kind of a good representation of what an SPC database might look like. You might have a products table. So in this table, it might have a product code, what the product is, what the test is, the last time the specs were updated, the target, the lower and the upper limit. So I'd like to somehow get these into Dream Report so that I can dynamically set the upper and lower limits and only create a single SPC definition. I don't want to have to create an SPC definition for every product that I have here. If it's all hardness that I'm testing in these, I shouldn't have to have a hardness for carbon steel definition, a hardness for iron bar, a hardness for aluminum. I just want a hardness test, and that's kind of the approach you want to take with SPC. And then depending which product you want to report on, dynamically filter out the appropriate data. So this is my spec table, and then we actually have the measurements table, which has all of the raw measurements, and simply saying that this is the code and this was the measurement. So it's hard to kind of tell what's in here. So really what you want to do is do a join across the two tables so that you can come up with a result, which is the sample time, the actual measured value, which product it was, which test you were running, etc. So if you use SQL, that's great. You can either build it all here and then copy and paste the SQL query into Dream Report, or use Dream Report's visual query builder. Or one of the beauties of Dream Report, another nice feature of Dream Report, is that we have this ODBC communication driver, which allows you to map into a table without knowing any SQL queries at all. So for that SPC data table, I simply chose an ODBC connection. I picked from my database the table, which was our SPC table, SPC measurements. Yeah, we have it down here somewhere. And then all we need to know from that table is which column has my timestamp, and so we found that. Now you might ask yourself, well, how do I filter out by the hardness test, or how do I filter out by carbon steel versus aluminum as the product that I want to test on? We don't have to worry about that now. That can be specified in the SPC definition. For now, all we needed to do was map into this database table. So we have that here. Now what I'm going to do is create a new report, one more, and we'll just call this ad hoc or on-demand SPC. And I will put my final report in here. So apply my template. Okay. So what we have here is we'd like to give our user the ability to select a product, so using one of the Dream Report's web elements. So this is a report designed specifically for the web, for the Dream Report web portal. Its output format is a web page, not PDF. I mean, we could make it PDF as well. On this, we dropped a combo box. And what do I want this combo box to do? I want it to show a list of 3 different products. And so behind the scenes, values of 100, 200, and 300, if you remember from my query, these were the actual product codes. So I want them, the user will see the descriptive name, but Dream Report will work with the product codes behind it, so we can alias those. And you'll see where we're going to use that shortly. The next thing is a date range over which the user wants to report. And then, based on this lookup, when I click on a specific product, and so we haven't even looked at the SPC part of it yet. This is just little objects in Dream Report, single data objects. I want to put 3 single data objects on my report that will look up the target for the selected product, the lower spec limit, and the upper spec limit. So by dropping an object on the report, I've just called it single data object lower spec limit. Where's the data coming from? So I've mapped into that SPC products table, and I found the product lower spec limit field. So again, I'm not writing a query. Dream Report just exposes that table to us as if I was picking a tag. And the advanced SQL condition is get me the product where the product code, so product code, equals what the user selected in that combo box. So now when the user selects a specific product and then updates this report, it will first go and query the specific lower spec limit for that selected product and populate that object there. Likewise for the target, I'd browse to the target field, and again, the advanced SQL condition is where it get me the target value, where the product code is that. Maybe I wanted to get the last value because if there were spec revisions, I might want to make sure I get the latest spec limit. And then finally, the same for the upper spec limit. So bottom line is, after we've selected our product and we hit refresh report, Dream Report will first figure out the target, the lower, and the upper spec limit. Now we can go to our SPC definition. So this hardness test, what value are we looking at? Well, we're looking at that measurement value from our SPC measurements table. Okay. I could have done this data source to be based on a query, but I wanted to show how easy it was in Dream Report just to map to it using ODBC and then pick any of the columns as a tag. But I don't want to then base it on all of the values, but only for the specific value product I'm working on. So now I'm filtering this data. Instead of giving me all these calculations, only all the raw values for my SPC calculations, only use the values where my product code equals the selected product code up here. So when I was building this advanced SQL condition, all I did was browse for an object on my report. So I said I have an object up here called combo box products, and it's in here somewhere, dynamic object. No, it's from analytics. Up here, and where is it? Products. Okay, and then you add it in, and so that's filtering out by the specific product we've selected. So that takes care of that. We're getting that column, only getting for the specific product, the data for that product. I'm going to now use sample base. So since these were measurements taken as needed, we'll use them just in a continuous every 3 measurements to make up a sample. And now for the target limits, instead of me hard coding 50 plus 3 minus 5 or whatever calculation or whatever hard numbers I want in here, for the target, instead of me putting a value of 50 in there, for instance, all I need to do is double click in here and I can browse for single data objects on this report, and I want that single data object target. Or for the lower spec limit, come here, go to my single data object, lower spec limit. Dream Report is smart enough to know the dependencies, so it will first do the calculations before the SPC definition goes and tries to look for them. So it knows there's dependencies and things need to happen in a certain order, so we take care of all of that ahead of time. So that was it. The first thing was to calculate the limits, so we could either query them or calculate them, and then Dream Report simply references those objects, those existing objects from our report by picking those up here. Okay. So to summarize, pick the tag from our data source, apply a filter to only show the measurements for that specific selected product, and then based on that selected product, go find the looked up spec limits and use that. So now I can make a single SPC configuration for hardness, not aluminum hardness, carbon steel hardness, raw iron steel, or excuse me, raw iron hardness. It's a single SPC definition. All right, so that definition is set up, and now it's a matter of putting some single data objects on our report, or web elements. This is our from object, date and time with a start, date and time with an end, and then I put a action button on our report. It simply says refresh the report and make a dynamic change. Oops. So actually, no, we didn't even need that here, the product code. We didn't need that at all. So what ties all of these charts then to this time period? For the time period, it's not fixed. It's not batch-based. What we've said instead is calculated. And now reference an object on our report with a start time. That was our time picker start. And reference an object on our report with an end time. And that's our time picker end. Okay. And we do that for all of these. The last thing here is a set of calculations. So based on the specific report or the specific product we've chosen, we want to do, the single data objects I showed earlier on, the calculated standard deviation or the mean or the CP or CPK. Again, choose our SPC calculation from here. It's CPK, which SPC definition, over what time period, and there we have it all taken care of for us here. And so all I did was put a bunch of these different ones on a table. Last option I put here was another action button that if I like what I see, I might want to save it off as a hard copy or as a PDF. So let's take a look at this now and go back to our web portal. And I guess I need to reload that report. So let's reload our reports. And we can go to the website now. Okay, so it defaults. I think I've defaulted it to the last couple of hours, and the carbon steel is the default. So let's choose a different product, raw iron. I'd like to look at that raw iron bar, and I'd like to look at it on the 12th at midnight up until the 12th at, let's say, 4 a.m. or 3 a.m. Done. Now that I've chosen my product, my time period, refresh my SPC chart, we should see the selected product now being the raw iron bar. The spec limits from our lookup table were 55.4 as the target. Let's go and verify that. 55.4 is the target. The lower limit was 53.2 and the upper was 57. Okay. There is my control chart. Everything is nice and tight, so my spec limits are actually greater than my control limits. So this is showing me I actually am running in a very tight range and with acceptable variability. So this is an ideal SPC chart. This is always what you want to see in the SPC world, that your control limits are inside of your spec limits, so it means you're really running with some tight control. My data distribution is good. My ranges could be a little tighter, but acceptable. And my CP value is definitely in the good range, not above 1.5, but good enough. Let's just choose. Let's go to now, see what we've been doing for the last hour or two. Let's just go back. Okay, a little dip over there, but still generally good. CP above 1.5. And I can choose a different product, aluminum rod. And so that, I think, is really where a lot of our customers or you guys are going to want to head towards, is an interactive chart like this, or a screen where you can actually then choose products, choose date ranges, choose specs, etc., and now have it all dynamic. So this is a lot more, this is certainly very useful, I think, for real-time SPC or on-demand SPC charts. I like what I see here. I do need to keep a copy of this, so let me simply click my Save as PDF button. And let's see what happens. It gives me a nice little printout to print, and there's exactly what I have for my chart as a printable SPC, as a printable PDF document. All right, so that in a nutshell, in a 1 hour nutshell, is what the Dream Report SPC tool set or add-on is all about. I really think it's a great add-on to any Dream Report installation. Yeah, as I said earlier on, the real benefit of using Dream Report for your SPC reporting is that you can combine data from completely different and disparate data sources that were maybe logged in different formats, in a PLC, in a CSV file, in a SQL database. Bring it all together, contextualize it with your other quality or maintenance or process data in your reports, and really get a real understanding and the implications of the different factors that are on your product and process quality. So, if you already have Dream Report, you would like to start playing around with the SPC functionality and you don't have a license for it, no problem. Please just contact myself or Roy, and we'd be happy to give you a 1 month or 2 month test license, which will include the SPC option, and you can start playing with it. We have some recorded videos on the web portal as well, and I'm sure Roy has, well, I think with today's recording, we will post this webinar as well. So please visit dreamreport.net, go to the downloads. If you don't have Dream Report already, get the latest version, and again, ask us for a license, and we'll be happy to give you an evaluation license.